Right, so today this is the tutorial 7 question 1 solution guide. So if in the lectures I only show you the applications or example on absorption, but now I would like to just share the steps for stripping, which is similar to absorption. It's just that the solute is transferred from liquid to the gas phase. So you can read the question. Countercurrent stage stripping is to be used to remove a taint from cream. The taint is present in the original cream to the stripper at a concentration of 20 ppm. For every 100 kg of cream entering per unit time, 50 kg of steam will be used for stripping. It is desired to reduce the concentration of the taint in the cream to 1 ppm. The equilibrium relation between the taint in the steam vapor and the liquid in cream is Ya equals to 10 XA. Ya is the ppm of taint in the steam and XA is the ppm in the cream. Assume that none of the steam condenses in the stripping. Use ppm in the material balance to determine the number of theoretical stages needed. So here what you can do is to first visualize the problem. So you have a tower, a stripping tower in this case. So this is still stages, a tray tower. So you have liquid inlet, is your cream, it's L0. Let's use the basis as given, 100 kg of cream entering. So 100 kg here. And then the X naught, because here the solute is in the liquid phase. So X naught is not 0 here. So X naught is 20 in terms of ppm. Right, so then at the end, at the bottom of the tower, you have Ln, and then you have Xn. So Xn here, you want to reduce the concentration of taint in the cream to 1 ppm. So Xn here equals to 1. And then for the steam, which is the gas inlet, so Vn plus 1, and then Yn plus 1. So Vn plus 1, so we use the basis also. So for every 100 kg of cream, 50 kg of steam will be used. So Vn plus 1 equals to 50 kg. And we assume that it's a pure steam unless stated otherwise. So Yn plus 1 equals to 0. So here you have V1 and then Y1. Okay, so alright, in this case we need to make some assumption. Assume dilute, very dilute concentration. So we assume that L0 is equal to Ln because it's very dilute. Because whenever the concentration is using ppm, then you know that it's very dilute. So L0 equals to Ln equals to 100 kg. And also for the V phase, the gas phase, Vn plus 1 equals to V1 equals to 50 kg. So you can put here Ln equals to 100 and V1 equals to 50 kg. Then we can find out the concentration of solute in the outlet gas, i.e. Y1, because when we want to plot the operating line, we need to know the concentration at the top of the column and at the bottom of the column. At the bottom of the column, we know 1 and 0. At the top, we know 20, but we don't know Y1, so we need to find out what is Y1. So let's do a balance on taint. So taint balance. Inlet equals to outlet. L0 X0 plus Vn plus 1 Yn plus 1 equal to Ln Xn plus V1 Y1. So L0 is 100 times 20 plus Vn plus 1 is 50, but it's 0. So and then Ln is 100 and then Xn is 1 equals to plus 50 times Y1. Then you solve for Y1. You get Y1 equal to 238 ppm. Okay, so here you have Y1 equal to 38. So you have your coordinates for the operating line, i.e. One point is 20, 38 is one coordinate, and another coordinate is 1, 0. So you can plot this on the graph. Okay, so you have your concentrations already previously, so you just take a note here. The inlet concentration here is 20, outlet is Y1 is 38, and then the outlet concentration is 1, and inlet concentration here is 0. Yn plus 1 equals to 0. So here here this is the dilute end of the tower, and at the top of the tower is the concentrated end of the tower. As you see, the concentration of solutes are higher at the top of the tower. Okay, so when you want to plot the graph, you can use Excel. So you can put in the Excel one table for operating line. So the X and Y values are stated here. And also one table for equilibrium line, i.e. y equals to tan x. So when x equals to 0, y equals to 0, and we just put something that is larger than what the value that we have in here. So I mean, you can put any number. So this is just to visualize only. Okay, then you can use these points to plot the graphs of operating line and equilibrium line. So if you can see the graph here, the equilibrium line is the yellow line, and the operating line is the blue line. So this is the dilute end of the tower, coordinate 1, 0, and this is the concentrated end of the tower, coordinate 20, 38. Okay, here is for the equilibrium line, this 0, 0, and this is 8, 80. Doesn't really matter. Okay, so now the next step is to calculate the number of stages. What we do is we'll step off the stages. So, so in absorption and stripping, you can either step off from the concentrated end or from the dilute end. So let's first do what you get for the number of stages when you step off from the concentrated end. So this is the concentrated end. This is the dilute end, bottom of the tower. So you can draw a line here from the concentrated concentrated end of the tower. Draw a line, then draw a line. It should be straight here, but I'm trying. Okay, so here this is a one stage, and if it actually reaches here, it would have been 2 stages, but it's not, because if it's 2 stages, then the concentration is less than 1 ppm at the end of the tower. So instead of 2, you have something like this. Then you can say that it's 1.9 stages, maybe, if you step off from the stepping off from concentrated end, right? Another choice if you want to step off the stages from the dilute end of the tower. Okay, let me erase this first. Okay, if you want to step off the stages from the dilute end of the tower, you can do that too. So we draw line for one stage. Okay, and hypothetically, this would have been 2 stages. This is one stage, and it would have been 2 stages if you were to reach at the end of this point, but it's not. So you only stop somewhere here, halfway through. So from this distance, you can say that maybe it's 0.6 of this distance. So if you can estimate it, it's about 1.6 stages if you step off from the dilute end of the tower. Okay, so that's all for the tutorial. It's quite easy. Actually, absorption and stripping are easier than distillation. Just to highlight to you the difference between absorption and stripping. So if you just see, I told this in the lecture also, but just to highlight to you, in stripping, the operating line is at the bottom of the equilibrium line. If you see, this is the operating line, and then this is the equilibrium line. So it's vice versa for absorption. Alright, thanks.